I've tried all sorts of spirit can stoves and found that the best design is the ultimate spirit can stove demonstrated by Josh of Survive Until Rescue on YouTube. This stove is not only one of the most efficient, but is also stable and safe to use without a trivet. The ultimate spirit can stove can be made from most standard drinks cans, so the materials are easily available from waste bins. The stove Josh makes on his video is a precise piece of craftsmanship and requires a variety of tools. However, you may want to make one of these stoves away from home, and I thought, how could I make that stove with the minimum tools possible? For instance, do you really need a drill bit, a clamp, or even a ruler? I came to the conclusion that the stove can be made with a pair of scissors, a nail, possibly a pin, and a straight edge. To demonstrate for the video, I will use a marker pen and some coins, but you could get away without these if you get to know your cans. The stove is made from 3 components: the top and burner, the bottom and fuel well, and the all-important inner liner. It works by boiling the fuel between the liner and the outer wall. This forces fuel vapour through the jets. All the components you make have critical measurements which, if you don't get right, mean the burn won't happen properly. The top is 1 1/4 inches in depth, the bottom is 1 inch in depth, and the liner is 1 1/2 inches tall. By happy coincidence, in the UK, a 2p coin is about 1 inch in diameter. The thickness of £2 coins make 1/4 inch, and obviously £4 coins make 1/2 inch. You could say, if you have that much in your pocket, you might as well buy a cup of tea. But if you get to know your cans, you'll find if you turn a can of Coca-Cola upside down, 1 1/4 inches is at the base of the apostrophe on the Coca-Cola label. And with the can the right way up, 1 inch is a line running above the nutrition information labels. Of course, if you're not from the UK, check your own coins and cans for the measurements. From here on, do everything in correct order, because once you start cutting the can, it loses its rigidity and will collapse and buckle. I'm using a pen here because it's easier to see. However, you could scratch a line with your scissors. Now, using your scissors, cut away the can top. Slice from the hole towards the edge. If you have the right type of scissors, you may be able to score a line to make a neater finish. Mark up the burner holes. I'm going to do 32 by eye and without measuring. First, make a mark. Then by sighting, mark one opposite it. Turn the can 90 degrees and judge the halfway point between your marks. And then mark opposite this. And carry on splitting the distance in halves. Turn and split the distance. When they're about 1/4 inch apart, you've finished. Now punch holes with a pin. Just above the bevel you may find a line of graphics which help you place your holes. If you haven't got a pin, you might use a nail. The pin is useful because it takes less pressure to pierce the can wall. The stove will work with pin-sized holes, but primes faster and heats quicker if you widen the holes with the end of a nail. With a couple of fingers inside the can supporting from below, punch a hole with the scissors about 1/4 of an inch in from the line you mark for the top section. Cut carefully, fairly roughly, parallel to the marked line. Hold the can like this and trim up to the marked line as accurately as possible. The hold looks a little awkward, but it exploits the way the scissors work best. Now, ease the top section over the base to stretch it. Then remove it. Now do the same for the bottom. Make sure that there is at least 1.5 inches of undamaged can wall left for the liner. Cut straight through the remaining roll of can wall. With any straight edge, mark a line as close to the rough edges as possible. It is important in this design to have at least one perfect straight edge, otherwise the liner can't make a gas-tight seal with the top lip of the can, and the burner won't work. This point is where the coins might be useful, but rulers are okay too. Parallel to this line, mark and cut out the other side as exactly close to 1.5 inches as you can make it. It mustn't be more. Fit the liner snugly into the burner top. Seat it down carefully. Mark with your pin in the centre of the overlap on both the inside and the outside. Now snip to just beyond halfway. Turn it round and do the same with the opposite side. Make a cylinder, check it, and if it doesn't fit exactly into the top, adjust the length by making another slot. it should fit snugly. Now make a slit as small as possible. You make 3 slits. These are the fuel holes. Bend a little triangle back to let the fuel through. Take the bottom and pre-dent the top evenly all the way round. Now you need to fit the pieces together. Holding the top upside down so the liner doesn't fall out, fit the bottom inside it. This is tricky. Ease the parts together so that the liner is held firmly by both top and bottom. It must end up with a seal between top and bottom, and also with the liner sealed inside the top rim. So we're ready to test. As I said earlier, it works by boiling the fuel between the liner and the outer wall, thus forcing the fuel vapour through the jets. I'm using methylated spirit. However, most flammable liquids work on this stove, including bioethanol or denatured alcohol and surgical spirit. Depending on conditions, after about a minute, jets will ignite from the hole. The stove is now primed. Putting a vessel on the top snuffs out the centre flame, and the jets continue to burn by recycling heat from the walls and liner. As things heat up, the stove becomes pressurised and burns very efficiently. I've found that the most efficient way to boil water is to allow the flames to run around the outside of the vessel. Being a purist, I like to use another drinks canner as a boiler, because you can probably find more than one in a waste bin. With an empty can, pull the ring pull up into a vertical position. Fill with water and set directly onto the primed stove using a stick. It will boil pretty quickly in still air, but I've noticed that these stoves don't perform as well outdoors as they do in the shed tests, especially the ones I've found on YouTube. So a windbreak is essential. Fortunately, any piece of cardboard will do. I don't think the windbreak works just by protecting the flame. It's much more about the cooling effect of wind on the boiler. When it boils, the boiler will vibrate quite a lot, and it might even fall off if you're not careful. So pick it up with a stick and use another stick to pour into your mug. In the UK, there is no real wilderness, but there are places with no cafe or they're closed. However, you're never far from a tin can. If you want to brew and you need to while away the time, pick up a can.